Yeah, started.
Oh, yeah. So our first question is like we have to find the shortest superstring. So we are given an array A of strings and find the any smallest string that contains each string in A as a substring. And we may assume that no string in A is a substring of another string in A. Okay. So here none of the characters are matching here. I mean series of characters. So like I mean you concatenate the entire thing that contains okay that yeah. And coming to this, we have matching right. Your CATG, no CAT is yeah
Yeah.
CAT like this. Your
Yes.
CAT is matching this.
Uh, mm,
No,
well, yeah, they actually merge together, you know, but we don't have a CATG because you can't have a complete string as a substring.
substring. Yeah,
Right?
yeah, yeah.
So you'll have CAT, but yeah, that is not actually, it is, if you look at it, CATG is already there, and then it has been merged with some other, or maybe some other one has been merged with this one, right? Yeah.
Yeah. So it can be like either exact this or reverse any arrangement of CAT, right?
Mm.
Like
You
is
will have to keep the order of the string as is, correct? But you can actually merge, means overlap with the prefix and suffix of two strings, either of
okay,
it, like, right?
okay,
Yeah. So if you take an example like this, let me see if I can. Okay. So if we have this uh, example, will be in this case a good one should be uh, not okay. If we have something like CATG, right, and
yeah,
then you have GCTA. Okay. So here you see G and G of these, the suffix and prefix are same. So you can merge like the CAT and then you have G
GCA, yeah.
CTA, right?
Mm.
So this is one way. Had it been like if you want to merge the prefix of this guy with the suffix of this, that also should be fine if they are matching. But
Matching.
here, yeah, if here they are not matching, so what will happen now in that case will be CATG, right? So
GC.
if you look at, yeah, so this will be a length of 8, correct?
Yeah. Yeah.
And this is going to be a length of 7, correct?
Oh. Mhm.
So therefore, we will prefer this one over this, correct?
So possibly you generate all the prefix and suffix of both the strings and then check, right?
Correct. Actually, that's what the problem is,
Yeah.
exactly what you stated. But there is an order to do, okay? So if you do it in an order that way, so what will be the order in that case? If you look at it, what we can do is, if we are at this level, okay, means if we have this example two, and then we try to merge these ways, you know, each and every string with case one and the case two, okay. So the case
Yeah.
one is the prefix of string A with suffix of string B, and second case is prefix of string B with suffix of string A. Correct.
String. Yeah.
Yeah. So if you consider that one and two as A and B, and then whichever is the minimum, if we pick that, okay. So, but for that, what we have to do is we have to go through each and every string and do the combination. Like I start with this one, this first one, and then I combine with second and see what is the biggest, smallest actually. Then I move from 2 to 3 and do a combination of 1 and 3, okay, as I did for 1 and 2. And then
Yeah.
whatever is the minimum of 1 and 3, Okay, and I just make a list of each and everything. Now in this case, if I suppose this is a combination of 1 and 2, okay, which is the most minimal, okay, then I
Yeah.
go and do a combination of 1 and 3, which is also most minimal. So maybe something like XYZ, right? So this is 1 and 3 and 1 and 2. So I go and do for 1 and 4, okay, and then I go and do for 1 and 5. So when I have all these combinations of 1 and 1 with all of these 2, 3, 4, 5, okay, I write it down, and uh, and after that I take 2, okay, and repeat the same thing again. But in this case I don't have to go to 1, but I have to go to 2 and 3 combination, 2 and 4 and 2 and 5, okay. Same thing I do for 3. And then when I have a list of all the minimal combinations of all these pairs, okay, and then I pick the one which has the biggest size. Okay,
Yeah. Yeah.
yeah. So in this example, if I think like, okay, my 2 and 5 gives me a result of a bigger one, which but a concatenated one, a most minimal one. Maybe something in this case it comes to like CTA, okay, and we don't have it. I don't think so. It combines anywhere. Maybe it combines the other way. CT, no. Okay, so whatever the combination is, I keep that combination, okay, and remove this 2 and 5, okay, from my search space now, and I take this 1, 3, 4, and this new combination, and do the same thing again what I did for this the first level. So now I'm going to level 2, and I'm trying to do this way the same thing what I repeated at level 1. So I do this when I reach level 2, okay. So I again go and do the same thing for level 3. So what I'm doing at level 2 is I'm actually combining two strings. Okay, now my level 2 will have a combination of two strings combined together like that. And then I go to level 3. In that case, it will be like another 2 and 2 strings combined together will be 4 strings, and so on and so forth. So at the end, I will be remaining with only one string, which is the most optimal one.
So when you
Yeah.
first uh, go level one, you were saying that uh, let's say suppose you're done with one already, right? Now you start processing two, and you try to combine two and five, right? But
Mhm.
then after that, you still need to consider one
Okay.
because because
Exactly.
one can be a prefix or a suffix of the new string.
Formed. Yeah.
Yeah, can combine with as a prefix or suffix with the new string to create another one, right?
Yeah. So if I take a simple example like ABC maybe, and say maybe E D, and then I have E something like D E D G A. Okay. So I have only three strings, 1, 2, and 3. Right. So what I will do is I'll find the combinations between all of these for the level 1. Okay. So now what I'm doing is I'm going to find a combination with A, B, C. It's not going to be different, right? Even if I do it swap it either ways. So this is one combination. And now with A, I can just find it is still EDGA, correct? Because A can go here in the third one. Then I go with this guy and this one. So in this case, if I find what I'm left with is BC
EDG.
EDGA, right? Yeah.
Yeah.
So now if you look at it, and so this is the biggest one. Okay. So I do throw these two completely, and I pick this one. But when I'm picking this one, I know it has come from this one and this one. Okay. So what I do is I remove these also. Okay. And what is remaining is only one A. So now my search space actually for level 2 becomes like this. Okay.
Yeah.
So
This.
this was at level 1. Okay. Level 1. And now I come at level 2. Okay. So why I am actually discarding these two? Because I found the optimal solution over here for these two. But for
Mm.
this, I haven't, right? So now I have to use this guy along with this one. Okay. And I'm just taking a very small example. Actually, this is not a sufficient one, right? If you have a bigger one, like even the example 2, it will be more number of combinations we have to do. And we'll have a very limited space on the screen to show, right? So now in this case, if I do this, okay, in this case, it's only 2 of them. And I know this is the most optimal one. Okay. So then I return because I will be at level 3 in this case because I've combined both of them together and I have only one string now.
So
Okay.
first you do all the combinations and pick the longest string, right?
Correct, correct,
And
exactly.
then the longest string is found from whichever strings you remove them off from the queue, kind of,
Right. Yeah,
and then you play with the remaining. Okay.
yeah.
So you use the all combination or permutation,
So it is almost like the permutations. Yeah. Each and
right?
every
Okay.
permutation and combination you have to use.
Yeah. So
So,
you add add in front or back both side.
correct. So it's a combination and permutations both together, right? So
Okay.
because from level 1 to level 2, what I'm going actually doing with the combinations. But in fact, if we look at for all the levels, I'm doing all the permutations also because we'll have to do it.
Yeah.
Depending on the
And
prefix suffix match.
Yeah, yeah, go ahead, Shashank, Harshit.
And I'm saying depending on the prefix or suffix match, you are appending the strings.
Right, right. See
yeah,
this? Yeah,
I
Harshit,
mean,
go ahead.
yeah, why did you cross C and G? I joined a bit late.
Not
Because
CNG. These full string actually.
I
Okay,
just
okay,
removed
Yeah.
the whole
It's not
string.
just the character.
Yeah. Well,
okay.
this problem is a very hard problem, and actually, I've seen people solving it with the TSP
traveling,
way, right? The
that's
traveling
just
salesman problem,
yeah,
and that is a good way of doing it. Exactly works, but
So,
that
so
might be an overkill.
this should be the hard, super hard problem, I believe.
yeah, hard, yeah,
Right, right.
super.
But
Looking at the constant, it looks like the complexity should be really high.
yes, yes, because the TSP takes a long time, right? And the time complexity
Yeah.
is huge, n square exponential, maybe even if you use a DP. And that still works, okay? But when I was going through all these discussions and all those forums, I found this one, what I'm describing here, gives you a very better time complexity. It's similar on the same lines, but not exactly the way that ESP is.
Mhm.
It's like yeah,
Yeah, if you look at it exactly what the way I'm describing, it's very simple. Okay. If you
yeah,
don't have to go the TSP way is very difficult to even understand in this context, because what we have to do in TSP, we have to take this string, okay, and
yeah,
then keep on finding the path for this one. When I'm done with this, I go with this string, okay, and then I even include this one and then find the most optimum path with this. Then I do the same thing with third, fourth, and fifth. So whatever the path I find for all of them, so if you look at only one, this of one, if I take the first one itself is a TSP. So this is another TSP. Okay. So you
yeah,
have about n TSPs, and out of that you find the most minimum. So that time complexity is very huge.
yeah.
Yeah. So at first, did you like choose any two strings, or you are going in some order?
Well,
So you.
in this case, I actually start with the first string, okay,
Mm-hmm.
and then I combine with two, okay, then one with three, okay.
Okay.
So that is one combination. Then after that, I pick two, then I don't go back to one. So two and three. So I just keep on going from my left to right always.
Also,
Okay. And
you are not checking with 1 and 3.
No, I don't. I check with one and three. I check with one and two first. Then I check with one and three.
Okay.
okay. So when you check with 1 and 3, you get EDGA, right?
Right,
Yeah.
EDGA. Yeah.
And when you check with 1 and 2, you get ABCE.
Yeah, yeah, complete this one, ABC.
Okay. Now you are checking these two, is it?
Not two. I think when you check 1 and 2, so you get ABCE or BCEA,
Mhm.
right?
Yeah,
Yeah, BCA. So out of that, whatever is minimum, I think both of them are remaining the same. They are not going to change as per the size, right?
Right.
Yeah. So and then you have EDGA. If we just take, so it is not EDGA. In this case, it is AEDGA, yeah, whatever it is. So this
Yeah,
one,
AED. Yeah.
and then if you combine these two, so this actually, even if it is the optimum one with both of them, so but if I compare this first combination, second combination, and third combination in level 1, so this is the biggest one, right? So I take this guy and I discard these two and three, and then I again start with whatever is remaining, that is only one, that is A. So if I
So at level,
combine 3 and A, then I get my answer. Yes, Shashank.
I'm saying at level 1 only two strings you are combining. At level 2, then whatever new string you formed, you remove the children from where you formed it, and then you compare with the next,
Right.
right?
Yeah. If I show you the implementation, you will understand it very quickly. It's very simple.
When you combine 1 and 2,
Uh-huh.
you will have you have two string, right? One is A is a prefix like A B C E,
Hmm.
and the second string will be B C E A.
Correct. And I
And
will
then
take the most optimum or the most minimum length of both of them. In this case, I can take either of it.
yeah, what was the reason? What the most optimum? You say the longest one?
No, I would always go with the smallest one. So I always want to get the most smallest one. So when I'm doing all the combinations, and when I'm done with all the combinations like this 1, 2, 3, when I've picked up, so but when I'm constructing this one, I will always pick up with the smallest combination, smallest size for forming this
Basically,
1,
it's
2, and 3.
tie, right? And then
Sorry.
in this case, it tie both length of string are equal.
Yeah, yeah, yeah. If you
Then
take a
you
good
you
example,
cannot pick one. You have to pick both.
you have to pick only one actually. So that doesn't matter much, whatever the way you pick.
Because you pick, like, let's say the first one, you pick the first one A B C E,
Mm-hmm,
right?
mm-hmm.
Then later maybe the second one B C E A would yield better result. How do if you
Well,
pick?
because we are always interested in the suffix and prefix. Okay, so if what will be the best thing to happen if you have a combination with A, okay, so then only it will be the best way. So you will have some other string which actually comes and takes this combination, okay, either the A is here or the A is here, okay. So if you are getting the best result out of that, that should not be a problem, right?
Right, but you have to consider both, right? Because if you pick A B C E, maybe A B is the uh you know match with suffix of another string, then pick that one would be better, right?
Yeah,
But
okay, maybe that might happen in the course of what we are doing, okay. So when we are actually reducing the one which we are getting, okay, so that might already happen in the whole process. So
Yeah.
it is the same thing like what we are doing, the way we are trying to find the minimum path, right? It is
Shortest
almost
one.
the same, but it's a slightly different way because we can optimize as the problem statement is slightly different than the TSP. Because we can take the advantage of the cost here. The costs are actually when we combine both of the suffix and prefixes. So whatever the intersection we can eliminate, that part, the maximum intersection we can eliminate, that is the cost, right? So that will be the minimum cost.
Mhm. Yeah, let's go through code.
it kind of overlapping, right? Two
Yeah, yeah,
string overlapping, and you want to take the one that overlap the most.
yeah. So that's exactly I'm doing here. Okay, so this is the main function. Okay, so this function actually does this all this thing, and this much is the only code here. Okay, So the way it is, this is just a vector string collection, and this is my A. I'm just assigning it to this collection, nothing else. And this is a while one loop. Okay. And I'm actually exiting this while one loop only when my collection size becomes one. And the way I'm doing is I'm starting two loops here. Okay. So the one is this first loop and the other is the second loop. And every time I'm going to I and j. Okay, so if you look at this, I will start from 0, but j will start from j plus 1. So when I take an I, j will always be more than I plus 1. Okay, so that is the reason I'm actually going from left to right always. So I pick these two strings. Okay, I'll take the overlap and I'll go back to the function later. So whatever this overlap is, for this time being, just assume that the overlapping actually gives you the minimal results always of the two strings, whether it is the prefix combination with suffix of fns or maybe the either way. So whatever is the minimal, it just returns the string actually. Okay, and then you just find whatever is the value of the current string. Okay, and so that current string actually you keep on storing its max size so far. Okay, only for the level one in this case. So whenever you find the max size so far till the end, you keep on storing where you are coming from, which are the combinations x and y in x and y, and this is your actual main string. You'll keep on storing here, and then when you are done with this first level, you come back here, and then you try to erase those two ones, and then push the new one. So that is the only thing what is doing,
Okay.
and then it goes back again in this collection in this while one loop. Okay, so it's removing the two strings and then pushing the one which is the most optimal one. It's very simple that way, the implementation. And also if you look at the get overlapping, so the function what it does is the similar what every overlapping is doing in this case. Like you take these two strings and he is having these two function variables a plus b and b plus a. There is a reason for this also. So he looks for whatever is the minimum of A and B, and then he compares. And if I is greater than M, okay, for now actually M will be 0, so I will always be. So he keeps on looking for which one is greater. So he's starting from the start position instead of going from the reverse. I don't know why they have done it. They could have done the other way also. But then you start from, and then you find whatever is the maximum intersection, okay, that you store. And in this case, you know that you are adding A to B, correct? This is because this is A, you are comparing with B. So that is what you're trying to do. You find this one, and then you come down here, and then you try to find the other way, B to A. And then the B plus 1 is more. So when you keep on storing at the end, you come out, and then you find which one is the biggest one, because you'll be going through both the loops, and then either b plus a will be 1 or a plus b will be 1. So whichever is the one will have the most maximum intersection, and that will have the least string, which will be the minimum combination. So that's the only thing what he does here, and this is also very simple function. And then you return from this, and then you just follow the whole thing, and every time you go through each and every level, and for every level you keep on reducing the two strings and combine both the strings, and so on and so forth.
Yeah. Can we do a very quick dry run for one example?
Okay, so if we take a dry run, do you want to take this bigger one? Okay.
Let's formulate our own.
Sorry.
I mean,
This is
let's
very big.
formulate our own example. It will be very
Yeah,
lot of
This one.
branches will.
yeah, we can go through that. It's not that big.
Okay,
Yeah, but if you look at it when you do, it becomes very big. Okay, let's try. So if I take this, okay, now my f and a is this one, right? So if this is my f, okay, and this is my s. Okay, now if I go to overlap, Okay, I'll have to remember these two because I'll have to come from here, right? So for this, we'll just go once for this guy, right? And I think this is CATC, right? Okay, CATG here only it is
CTA.
CATG. Yeah,
Yeah, you can see on the from the side.
yeah. So now if you look at this one, the minimum of this is in this case A and B is A.
4,
CAT.
yeah.
So it is CATA, CATG, and then I start from 1, and now I'm comparing 1 with length of A is 1, 2, 3, 4.
Okay,
Okay,
so
4 minus 1.
it's taking exact same number of the character from the first string
Yeah,
and the exact same number of character prefix from the second string.
yeah.
Yeah.
Okay, so you mean CTAA.
So it will actually compare with G in the first phase. It will compare with the G from this string, and it will try to check that whether the first character in the second string is the G or not.
So in this case, it is not, right? So I don't think it is going to compare and add anything over here, right? So here it's
Okay, 1 second. Why G?
okay. So if you see the length of A is 4, okay? 4
Okay,
minus 1 will be what?
3.
4 minus
3.
1 will be 3, right? So
That will be the starting for the substring in the first one.
yeah,
Yeah.
so this will be the starting.
Okay,
And then
and
actually
then
And I tell the length,
length, yeah,
length of the substring, so 1.
okay,
1. So
And
G
the,
is 1 and
yeah.
then B. Same
And
thing for B
okay,
0.
second, the substring will always start as 0
Yeah.
because we are comparing from the front.
So this
okay,
is
okay. My bad. I
not
thought
going.
G in the B we are taking.
No.
Yeah, yeah. Okay.
He's taking
I thought,
the
yeah,
suffix of this one and the prefix of this one. So they are not same.
yeah.
And then he will go again till the
It
end
will
of
break
this one, right?
immediately. Yeah, if it will not match it, it will go to the next, right?
Yeah, it will go
Okay,
all. And then if nothing matches here, right? So then it comes down. Okay, now here it is slightly reverse way again. So the first,
Prefix.
Swap the
so it will
G with
be
the last G, it will check here, right?
CTAA. What was it, Shashank?
I'm saying in the second this for loop 21. So last, I mean, the first character G will match with the prefix of that. What do you say? I mean, not prefix, the last character of the second string.
right now. You see that at line number 23. So just flip the string comparison.
Exactly. Yeah.
Yeah.
Yeah. So
yeah.
this T doesn't match here. This GT also doesn't match. Then AGT also doesn't match. So nothing matches here also, right?
So here you get.
So here actually you come for the last one, which is B plus C. So in this case, he will take this one. So which will be C, T, A, G, T and C, A, T, G. Right. So here nothing matches, right? So you'll have to take the whole
Okay,
thing.
so nothing matches.
Entire concatenation.
Yeah. So this actually comes here. And then if I take the whole thing, what will happen here? So now this is just for these two strings. Okay, this one and this one. And then I start making putting this in my string here because this will be the biggest one now so far because even if I compare all of them, the sizes are smaller than this one because it's a combination of two strings. So it is trying
Right.
to go through each and every one and try to find whichever is the string, whichever is the biggest two strings. Okay, and then you find
Okay.
whatever is the optimum one, so it will always be bigger than all of the ones which are in this one. So at the end it will be like that. The my string, my str will be a combination of the two biggest string, and then when you are done, in this case I think there might be something like these two get concatenated and then you get a slightly better one.
So what will your get overlapping doing if there is no overlap?
So this is what it did, right? So it came,
Normal concatenation.
it will just concatenate. So if you
Yeah.
look here, what it does, so it looks for A plus B,
Okay. Okay. So
and the return will always give B plus A.
Yeah.
It doesn't care for what happens with that, right? Yeah.
what is
What
your
does it?
M guys for?
Yeah, yeah.
If
M is for what?
M is 0 initially.
0.
M will
What
be
will
always 0 because it's not going in this. So it is the maximum so far length.
Okay, okay, okay. Yeah.
Yeah,
So
from the first string.
if there is no match, so that will be 0, right?
Yeah. Yeah.
Hmm.
So M will always be 0, so it will return the
From 0 to end.
So 0 to end. So it will be
it
0.
will
Yeah.
compare. Okay, it will append both.
Yeah. So it will happen. And so if we do this,
Yeah. So at the end of the first iteration, you have this in your mystr, right?
yeah, it's only the first two combinations, right? So now I have to do with this and this guy. Okay. And if you look at this
Yes.
and this, if the combination, the best combination is CA. In this case, I can just write it here, right? So it comes to CAT. G is common, so I can have CTA. Oh, sorry, G is there, right? Yeah. Okay. So I cannot have much smaller than this one, even if I do it the other way.
So
Mhm.
each step is actually merging only 2 string.
Right.
This loop, the whole
Yeah.
loop. Yeah,
Right.
these two loop just merging.
Yeah.
Yeah. So if I do like this, and so the first one was this one, right? So but when I come here, so I'm saving it here. But when I come for this one, this is smaller than this guy, so that is discarded. So the max so far is still this one, correct? So
Right.
this is completely gone. Then again I go for this one and this guy. Sorry, this one and this one, CATG. So then I again get CATG, and I think CA comes here, so it might be slightly much better if I do the other way, CTCA and TG, correct? So now this being a more smaller one, so this doesn't come here at all. Okay, so that will go away. And then if I combine these two, in this case, I think IATC, so I get a much better one if I do it this way,
Yeah.
CATG, right?
TG and CATC.
Yeah. So, but even if you count these numbers, 3 and 3, 6 and 7, 8, so they are still smaller than this one. This is 9
Mhm.
or it is 10, right? So this always wins, at least for when I'm taking CATG as the first one. Now, when I'm done with this, I need to start with this guy. Okay, I start with this guy and combine this one. Okay, in this
Okay, okay.
case,
Before that, what is the last part? Like from line number 73.
line number
This is
73. Yeah, so what happens
it is
is now
out of the for loop. Okay, it is
it
out
is
of the
out
for
of the
loop,
for
right?
loop. Yeah, yeah, yeah.
Okay,
Because I
good.
have to complete the whole of this one. I have to complete each and everything because there might be an option, there might be some other string which will give me a much better result, right? So I have to explore all the combinations. Therefore, it is an n
Okay.
square here itself. All of this
Got
is
it.
n square, and the outer one we have just one loop. That therefore it might be n cube. I think
Yeah, yeah, and cube. We have get overlapping also. No?
Yeah, no, but yeah, that is different. Okay, I have a while one here.
I mean,
Yeah.
infinite. Yeah.
So it's an infinite loop till this guy doesn't become one. I keep on doing it. So I have to,
Okay.
when I do this n square, every time I will have to reduce the size by at least by one string.
So
Okay. And
Santos, what is the intuition to keep the longest string?
I
That will cover
don't,
most of the. I mean, most of the strings can be derived from longest string, right?
yeah,
If you take the
Yeah.
shorter one, maybe only 2 words you can get out of it. But if you take a longer, it might be possible that 3 words you will cover with that much optimized string. So
Yeah,
well,
but
most
okay.
of
every time we
Leon,
compare
to
only
answer your
two
question,
strings.
I was doing this by all these ways, the TSP way. It's so hard.
so much fun.
I tried
This is
many, many options, one, two, three, some of them were TLEs and all that. It's very good to understand the TSP. Everything is very nice. Okay. And it's very interesting also. But then at the end, the time complexity which I found with this solution was very, very high. Okay. I'll just show you the difference. So I was always getting with these TSPs 184 and 180. And if you see with this algorithm, I'm getting 8 and 12. It's a huge saving. Even the memory was too much for the TSPs, because in the TSP you have to maintain all the cost, right? You have to calculate the cost every time you do it. Okay, so you do this, calculate this cost. It is exactly the same the way we do for overlapping, but you have to store all those stuff. Okay, and then you start from a string and go from each and every path. Okay, start with the one string. But when you go for in this case, what I'm doing is, so in the TSP, what it does, it takes this one and then it finds the shortest path with starting at this point. And then when it comes to this one, it starts with this, but it still take this guy also into consideration. Okay, but here what we are doing is, when we are starting from here, and then when we come here, we remove this because we know that we have found the most optimum string with this guy. So there is slight reduction in this. Okay, maybe this problem we can avoid using TSP to get a better time result, time complexity results. But wherever TSP is required, you still have to use TSP.
Okay.
Hmm.
So the
Yep.
longest string
Mhm.
in the first double iteration is always only combine of two string, right?
Yeah, yeah.
Yeah.
So, but when you go in the level two, means when I'm done with all of them, right? So I found something like this, okay? And then I eliminate whatever it comes from, whatever the X and Y are. Maybe this, I think it is this guy and this guy, I eliminate them. So now I'm left with this combination and 1, 2, and 3, correct? So then when I come back again in the while one loop, okay, then at the time I know this is the biggest one. Then I just have to find with these three combinations, okay, which, because I know this will surely come now. Okay, then I have to combine either of these three, which will give me the biggest results, and also the overlapping should be the minimal. Okay, so I'm
Mm.
trying to reduce that way. Okay, one by one.
Okay.
So,
Yeah.
so idea,
But why
idea
did I come by? Sorry.
go ahead, please.
So, but the way Leon was asking why I came with this, there's no intuition. I just followed it, and I found
Yeah,
this
so
implementation to be
the idea, I believe that the idea behind that is to actually reduce the complexity of the implementation. Uh, Here, there's an assumption made here that get overlapping will always, the assumption here is that it will return the overlapped string, even though there is no overlap, right? If there is no overlap, you can take whatever combination you want to take, and you will get the exact same result. But if there is an overlap, so the output string will always be bigger than whatever you have, right?
yeah, it has to be.
Output string would be it would be equal to the sum of the lengths minus the overlap, right?
Right.
Yeah.
So, but it will still be
So
bigger compared to all these
Yeah, yeah,
interval
it
that
would
ones.
be
is the
bigger, right?
difference. The saved is so here is at line 61. The saved is the number of character overlapped.
Right. No, actually, the saved is the
And that,
whole strings.
yeah. So the idea is that you are trying to actually maximize the overlap.
Oh, yeah, 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 you're right. Yeah.
So
Yeah,
that's
yeah,
why you are
yeah,
taking the difference.
Hmm.
yeah.
So, because
Shortest of
actually
longest.
overlapping gives you the minimal, and then we are taking the maximum of the minimum here, right?
Yeah. So you are actually, in a way, you are trying to find that which option is giving you the maximum overlap.
Yes.
Yeah.
Yeah.
Minimum of
And for that, I think
yes.
Shashank was right, right? He said that we are trying to keep it longest because for future strings, then it is possible to incorporate those strings.
Correct.
Yeah.
Yeah.
Because if, yeah,
Yeah. That is a correct statement, I would say.
I think it again falls under min max problem only, right?
Right. Yeah. I think so. It comes to that. Yeah. But is this doesn't look like a not a DP but a greedy somewhat,
right, yeah, yeah,
right?
Yeah, it's greedy only. Yeah.
I don't know, because but when Leon started asking, the question saying, okay, why we are doing this way, and if we could have done it the other way, like I was taking the example of ABC, and if it was ABC instead of BCA, So there might be some combinations in the future string where I could find CA, and make an optimized choice. So, and I take the other one. Okay, so he was saying, why not take both of them?
Yeah.
Okay, so I don't have an answer for that. But if you look at this way, maybe the test case what these guys have, they don't have those things. I don't know, but that is a very valid question.
Mm. You like in the you know, later you can test it in the overlap. Instead of return in one order, you return in the order, in the other order, right? And see if it still give you the right result. Like on line 37, right?
Okay, so in this case, I can just say like this, maybe B. Okay, instead of A, I will say B plus A. Okay,
Mm.
so I'll be returning it the other way. I can try
Mm.
that. Okay, this is the solution, right? I think it might work. At least the first one would surely work. Yeah,
It's
it won't.
amazing.
It doesn't work. Yeah, you're right. So it
Uh,
has to be done in a certain way.
uh, I have one doubt.
Uh-huh.
Like, can we do something like that? Like, uh, number of characters, like in the input first world, how many A's are repeating? So maximum number of A's, how many is it repeating? So we'll take that count, and similarly we will do for all the characters, and we will like.
No, it is a substring, not only about the repeating characters. You have to maintain the order of the characters also.
Yeah.
But in the first example, they are saying like they will also accept the permutation of that.
There is no match right in the first one, so they are concatenating everything.
Yeah, for
Well,
the first one is slightly different. Yeah. So you don't find anyone matching with each other. Another prefix of one. So therefore, if you look at this, it's the same string what is written over here.
Okay.
Same
permutation
thing
means
for that.
words. I mean, you can't change the letters of the word. Permutation means
Yeah.
love can first and then followed by LX and lead code. But
Hmm.
LX can't be XCLA or something like that. Combination of permutation. What do you say? Uh,
Yeah.
Yeah,
the
this
one.
permutation for these strings, not
Yeah.
within the string.
Within the
String. Yeah,
strings,
that is
correct? Yeah.
correct.
Yeah.
Yeah, we cannot
Yeah.
permute within a string.
Yeah. But yeah, this
Exactly.
this one is very correct what Leon pointed out. So this is something which actually is very important. Okay,
No, but
A
that
plus
makes
B.
sense, Santosh, because the overlap happens from B to A. So that's why you have to return in that way.
So you try when it not overlap. You know, you have an
But
if
see,
condition where
yeah,
they
but
are not
see,
When,
overlap.
so
You
when it's
return
not
the other
overlapped,
one.
it always return B to A.
yeah, but then why it has to be?
No, but if you want to change it, Santosh, if you want to change it B plus A, then you have to change it return B plus A dot sub strm. You have to change that too.
Yeah, it has to be the
Uh,
reverse then.
but if I say here B plus A,
So you have to change that next line too. B
okay,
plus A dot
okay.
sub
I
str.
got a point. Okay, my bad. Yeah, yeah. So okay, so either way, whatever we return, it will return. Yeah, that is fine.
Yeah.
Sorry. Yeah, that is okay. But if you look at the TSP approach, that is also very interesting implementation, but it uses other stuff, and I won't be able to really go in detail, but whatever I've understood, so this is our string, and visited all is a bit mask, I think so.
Okay, they are using bitmask DP.
Yeah, bit mask DP. So if you look at
DP
this,
with bit.
it is
Yeah.
integer,
Mhm.
and if you come here, so the first thing we are calculating the distance. Calculating distance is the overlap actually what we are doing. Okay.
Right.
So for every string, whatever is the overlap that we store in the dist, that is a cost for us.
And
So it will be a
that
big one.
has to
2 by.
okay, to return the same what you are doing in get overlap.
Yeah, but in get overlap, what I do is, in this case, the previous case, actually it finds the optimal with prefix, suffix, suffix, prefix combination. But in this case, you will have to depend on I and j. So if I is one, so I will always be the first one, and j will always be the second one. It doesn't find the most optimal, but the second optimal will be in the case when the j and I are a reversed way. You know. So if you go here and then, so the k is one which we starts for each and every node, okay, assuming that we are starting from the first level, okay, and then these are the two, path and dp. This is the dp, what is memoization, and this is the path, okay, what we are storing here, and this is the tsp. So you go in the tsp, and when you're coming out of the tsp, for that particular tsp, you find what you construct your path, and this will be the result, and you find whatever the result so far, max so far, sorry, min so far in that case, and then you keep on storing that and its length, and then at the end you return the answer. Okay, so now this tsp is the whole thing where the main important things happen. So you are actually passing the mask, and initially your mask is 0. Oh no. So mask is actually you take whatever your node is, okay, and then for that node you create the first mask, okay. In this case, it will be the 0, so the answer will be 1 shift to 0 will be, I think the 0 string will be set to 1, right? So and then you have the position, and position is 0 because we are starting with the very first position of the node, and then this is our DFS, done very normal DFS. We look for the mask is equal to visited, means we have visited all the nodes in that graph, and then we return 0. And if it not, this is our memoization version,
Yeah.
okay, and then we are actually having an answer set to int max, and then we are going for the whole the Hamiltonian path, right? So go to each and every city, okay, from, but in this case we look for the mask if our city is the same what we are coming from, okay, we don't want to go there. Okay, so we avoid that city only, but we go, other than that, we try to go to each and every city. So when we are doing that, so this is what we earlier calculated overlapping. Okay, so we
Yeah.
take for this position what we are coming from as a parent, and then the cities for what we are actually uh, visiting on this level, and then this will be a distance for this particular city, but then we'll have to divide our sub problem for the other cities to the next recursion level, right? But we, before doing that, we take the current mask whatever we get from here, because we have set the 0th position when we came into this for the first time, along with the current city. So we are setting 2 of the bits over here, and then we are passing for this current city, so it doesn't go and overlap for these 2 cities anymore. Okay, so every city is always visited only once in this case, and then we return back. Here in this case, we again do result. What is the result minimum so far? Okay, here we are actually not storing the string, but we are storing the integer value, because we actually get the distance, which is the cost in terms of integer. And then we actually, when we are done with this, then we store in the path what was our best city,
Minimum one. Yeah.
right, the minimum for this particular mask and this position. So if you look for this mask and position, it will be when we came from the very first, it was only one city and one position. But if we are going in this TSP, we are going in the second recursion level, so we'll have 2 cities. Similarly, another recursion level will have 3 cities, and so on and so forth, right? So therefore this
So
path will always be filled in very properly.
mask is used for checking visited only, right? Whether visited or not.
But also, like every time when we come in any recursion level, you will have a city, okay, but if you go for the first level, you will have only one single city, but if you go to second level of recursion, you will have 2
Hmm.
cities, right?
Yeah.
Okay,
Oh.
so the mask will change, always the
Oh.
mask will change based on the recursion level.
You are adding to the previous mask, the current one. I mean,
Right.
you are doing the left shift and adding it to the previous mask.
Yeah. The reason we are doing is we want to visit each and every city, but we have to visit each and every city only once. Okay.
Yeah. Nice.
And that is what we come back here and we see the result has to be also minimal, because we have to find the shortest path for each and every starting city.
How do
Right.
you return a string?
Yeah, the string actually comes here. When we are done with this, we fill in this path value. Okay. We know this best city for each and every mask. Okay. At every time the state will be different, right? And also we are storing the DSP mask and position, whatever the answer is over here. Okay. So these are the two values which actually, so these are the two matrices which actually does this construction of path. So this path is constructed over here, and that is actually done when we complete one TSP. Okay, so when we complete one TSP, if you look at this path and DP, they are always reassigned when you go into the TSP. So you are doing it over and over again for every path, and when we are starting from a particular K, right? So then you form a path, then you store the result. So there's too much of competition happening over here. And if you see, this is the path, construction of path. You are passing our original string, vector string, and then you are passing the city what you started with initially. And from that, you know your path and DP. Okay, so you are using this path over here, or you only use a path over here. So you know from the path which is the best parent, and based on that parent, you pick up from that A string, its substring, and then you find the overlapping, right, with using this distance. And then you try to combine the exact string, whichever is the best approach for this particular city. And then also you update the mask. You have to do that because you have to find the correct parent, for the next level from this path matrix. Yeah, it's slightly complex to come up with a 45 minutes interview for sure, but I think the one above, at least we should be able to come up with this approach, right? This looks much easier, at
Yeah.
least for such problem, right? Yeah.
Yeah. Yeah, it's very unlikely that these questions will come in interview. Not sure, but anything can happen. Yeah.
Oh, wait.
Sorry.
Can
Yeah,
you explain? Can you go back to the source code?
okay. Which one?
So let's say we already done like no that one, like we already done the first nested loop and we find the longest string, right? And then now we go down to 73.
Mm-hmm.
What you do? You okay? You remove that string, huh?
Yeah,
Yes,
yeah.
yeah.
I remove all of them, but this is a very weird way they're doing it. I don't know. Maybe it's good way. They could use some other data structure. I think so. I don't know. Yeah,
Okay, I
but they
see.
are doing it this way. And if you look
So
at the whole,
every time it runs through that nested for loop, it combines two string into one, right?
yeah. So that
I
is
mean,
what
if
it
you
will
use
always
at
do.
mode two string,
Yeah,
okay, and finally, okay, got it.
yeah. I think this is a very smart way of doing it, and I don't think so. This guy might have come so quickly. You know,
So where
he
was
also
it
might have
asked?
filed a TSP. I'm sorry.
Where was it asked? I mean, in the section you see,
I think it was asked in Google. I think. Uh,
definitely.
yeah, Google, Amazon also. But this problem, if you try to solve it this way, it should not be a very difficult, right? If you
Yeah.
are actually following this way, only the overlap might be a challenge to do and actually implement it immediately. But these two for loops should be fine.
Yeah, now things are, I mean, much more clearer than before.
Yeah. But when I initially looked at this problem statement, I never thought it will be so hard. I thought it's just combining two. Maybe I thought maybe make a unordered map and do all the prefix and suffix of each and every string, and then keep on storing all those values. But then eventually I started reading, I thought, oh, this is not so easy.
Hmm.
I don't know.
Yeah, yeah, and that's true.
But it's
Yeah,
fun. Yeah.
yeah, definitely.
Yep.
So then we can switch to next then.
Yeah.
So this is like a search in a rotated sorted array. The integer nums is given with distinct values, okay, and an integer target, and it is rotated at some pivot point which is unknown to us, and we have to find if the target is found, return its index as -1. The target is 0, it's found 4. 3 is not found, -1. So these are the constraints. The values will be unique and it's guaranteed to be rotated at some point. Yeah.
So so there's a brute force way to go about it, right? At first, which is self-explanatory. You basically loop through all the elements at first. You find the target, return the index. Runtime is O of n.
Linear
But
search.
exactly, yeah, linear search. But we can do using binary search. The only tricky part is now if you few observation that we can make, right? So if you look at that array, the question says, okay, we have a pivot element. I know. So okay, if you look at just the array itself, we can see the array it's sorted, but it not sorted in a way we can directly use binary search. It's sorted in two halves, right? One half and the other half. Now the question also says there's a pivot element. Now when so on that first example, 4 5 6 7 0 1 2, pivot element is the one where element is greater than the left side and element is greater than the right side. So 7 will be our pivot element, right? So basically, we don't need to find the pivot element, but what pivot element gives us an idea that, okay, we have two half, on this array, where one on the other left side of the array is, the one half is in the increasing order and the other half is also on the increasing order, right? So that's the one observation we can make. The second observation is okay, the other half of the pivot sorted array, all the elements should be left and so in this example, right half, the elements are less than the left half of the array, right? That's a second observation we can make. So the whole intuition is, okay, we can use binary search, but we can only use binary search on a sorted array. So what if we find a way so that our target, which is 0, find an array, find that subarray where the target element is, right? So for in this example, if we see target array is on the right side of the array, 0 1 2. So once we figure that out, we can only do binary search on the right side of the array, and then our runtime will be O log n. So that's the whole intuition coming up with the solution for the O log n solution for this problem.
Yeah.
Yeah. Well said. Yeah.
So one small correction to that. So you mentioned that the pivot element is 7 because the but you can think that it could be 0 also, because in 0, so the left is bigger and right is also bigger.
The starting of the any sorted array or the end of the any sorted array. I mean, both the 7 can also be there or 0 can also be
Yeah,
there.
Yeah,
I mean,
yeah, you're right. You're right. Yeah.
So
But
you're
on
trying to
this
say like
question, it's asking us
5,
to find the like index, not the pivot. But you're right. Yeah.
0, 1,
No, but
2,
if you get your
and
target on the
4.
pivot only, then
Oh yeah. So if you get your pivot here, yeah,
Mhm.
that's a good one.
it can be. Yeah. So first search you have to make on the what you say on the entire array. Take the mid and check if target is matching with the mid. Why to make the further calls then?
Yeah,
Mhm.
the first thing what we should do is that let's check nums of 0 and nums of n minus 1.
Mhm.
If our nums of 0 is less than nums of n minus 1, then we can simply iterate on the entire array. Like on the
Yeah.
entire array, we can do binary search.
Yeah. Yeah. So yeah,
Yeah,
that's the
but
intuition, right? Finding that
even then
target in that array.
it will be
Mhm.
rotated for sure. So that case will never arise unsorted, right? The one you are saying
If
that
I
nums
say
of
that if I say the rotation is by the length of the array, then also
that's it's same only, right?
Yeah.
Yeah,
Okay.
but
Yeah.
you can find out that. So that will be a some initial checks to be done, right?
Okay.
Yeah.
Good.
Yeah. Other way, I don't think so. We can do it.
Even even when we are finding the pivot element, then we can extra check if the array is already sorted or not.
Come again, Abhishek.
Uh, since we must know which is the pivot element, so while checking for the pivot element, we can first check if the base case will be the array is already sorted
Okay,
while
the
checking the
initial
pivot.
check, right? Okay, okay, yeah,
Yes.
that makes sense. Yeah.
Mhm.
Yes,
Okay,
Sapal, you like to say?
so Safal,
So
Yeah, I can
it
share.
seems
is
like
it
you
given
have.
that the array is sorted in increasing order or decreasing order?
Uh, well,
No,
that's
it's
a good
rotated, so
question,
it's
right?
very hard to say, right? One part will be increasing, the
It
other
is
one.
ascending. It is says. Yeah, it is
Ascending.
said in that ascending
Ascending.
order.
Yeah, it's understanding. All right, so same intuition, right?
Okay. So
We're
what
gonna
is the
just
use
look at.
of, just
Mhm.
for a sec, I mean, what is the use of mentioning that ascending? I mean, even just the right sorted, it doesn't give any difference, right? Like any advantage, we are not taking of that.
No, then when we are doing the
I
binary
think it
search,
will be the other way
then
there.
yes, then when we would be doing the binary search, the uh, condition for going high or low will be changed, reversed
Yeah.
if it is
Okay.
sorted
Yeah.
in descending order.
Okay. Yeah,
Or
that's
descending order. Yeah, makes sense.
So here, so I'll go line by line, right? So we'll look at this example. So, all right. So the same idea behind finding my target element and which that's our first challenge, right? So in order to do that, first of all, okay, let's find the mid first. Okay, low is 0, high is 6 on this case, right? And if low is less than high, give me the mid, and the mid is would be 3, 0, 1, 2, 3, 7, right? And while low is less than equal to high, mid, and now we'll check, okay, is uh is nums mid is equal to target? No, it's not, because if it is, then just give just give me the index. Otherwise, it's not. So now here we're checking, okay, um, if it's not equal, tell me if if my target element 0 is on the left side of the array. We're asking, okay, tell me, is 0 in the left side of the array? It's going to check. On this case, it's not, but if it was, it'll say, if it is on the left side of the array, tell me uh, if my target is between these two indices, 4 and 7. If it is, then we're going to change our high. That means we're only going to get focused on this side of the array, right? That's what this else if statement is saying. Then if not, since we know, and based on the problem description, if my target element is not on this side of the array, then it has to be on the other side of the array, right? That's just natural, because it's somewhere in the array. And on our case, it's going to go on our else statement. So it's say, okay, now it's I don't even, that's why I didn't put any check, because I just naturally assumed that if it's not on the left side array, it has to be on the right side of the array. Now I'm checking, okay, tell me if target is greater than equal to mid or less than equal to high. It says yes, target is actually on this side of the array. Great. Then it's going to say, now move my low to mid plus 1. Where was my mid earlier? It was on 3, right? 0, 1, 2, 7. So now my mid will be right here, 0. My high would be 2. Low, then I'm only, same condition, I'm just doing it. Now I'm only focusing on this side of the array, right? So next time it loops, I believe low will be 4, 0, 1, 2, 3, 4, right? High would be 6, and mid it'll give us 5, 0, 1, 2, 3, 4, 5. And then the next time it'll loop, it'll both point to 0, and then it returns mid equals to target, return the mid. But that's the whole intuition, right? Figuring out first which side it goes, and then just focus on that side and do a binary search and return the index. If we can't find it, just return -1.
Hmm.
Yeah. So
And
I think
one more, what you say, I mean, a step ahead, had they given that there will be duplicates. So you just check if your nums of mid and low and high, all the three are equal, then you increase low by 1 and decrease high by 1. One more line you'll have to add in this code.
Right,
If
that will also be very important. Yeah, that's a
Yeah,
good
there were
point.
duplicates.
Yeah,
Yeah.
you'll
it's
have
in
to
set.
handle the
Yeah.
duplicates, right?
Yeah. Before that, it's shuffle, right? So
Yep.
you could have gone with the high also, right? Nums of high, like for the checking on line number 16 and line number line number 16. We could have checked our mid with nums of high also, right?
Mhm.
Is nums made, you mean less than high or?
No,
Yeah,
you'll
the
have
other.
to check it mid only, I think. Right?
No, I'm saying keep the mid as it is,
Uh-huh.
and instead of checking with nums of low,
Uh-huh.
we can check with nums of high also, right?
Yeah. Then else part will be the other one.
Yeah. So basically, yeah, you can just switch around. Here on my case, I'm saying, okay. I mean, we know what, I mean, both of them are in increasing order. We're only checking. Okay, if at first I'm checking if the element is in the left side. If not, then go to the right side. But yeah, you're right. We can do either way. Yep.
Yeah, there is a question on your code on line 30. If someone is, Ankita is asking on line 30, you're checking if mid is less than the target, which is the comparison of 7 to 0. How is that right?
I think he has made some mistake in line 30. It should be greater than nums of mid should be greater than target. Is this code running fully, right?
Yeah, this code runs.
No,
Try
it's fine. It's fine.
No, actually, she has just one okay comment on it. I think that, yeah, it is getting accepted.
Yeah, it's
No,
good.
because one place you are checking target less than mid, the other
Can you just see what is she saying on line 30?
What is she saying? Let's see.
You're checking if the mid
yeah,
is less than the target.
Okay, on line 30,
down
you're
arrow is there.
checking if mid is less than
Yeah, please minimize this here.
Line 29.
Line
You
29.
click.
Line
Is it
20, okay,
Actually,
correct.
that
less
is
than
correct.
target versus
Yeah, it's
Target
correct.
should be greater than mid and target should be less than nums high.
Did she mean this?
Mhm.
I think you are correct, right? Yeah.
Yeah, that means we are in this array, right? 7012.
Uh-huh.
So we are checking this part, and the target is 0, and our mid is what?
Oh, yeah, because we already checked our mid over here. So we can only, we don't have to check the same thing again. We can say target is greater than nums mid.
But still it was passing.
No,
Yeah.
because it won't reach here.
It will be taken care by the upper one. Yeah.
Okay.
Okay. That is.
But I've seen like this question, how many times you see, this can be always confusing.
Yeah. Not
That's
like-
really correct. Yeah.
Yeah.
Because this is like easily we can get confused with this. So to reiterate what Safal said,
Mhm.
So basically the trick is we need to find where we need to go. So in binary search, what happens? We have to change our left or low or high, right? So we need to change our low or high. So first find mid, then we want to see if we want to switch the low to the right side or we want high to come on this side. That's a whole process in binary search, three-step process, right?
Yep.
So in this case also, if we want to do this thing, so initially if my mid is here, and now it's a two-step process with some more sub-steps. If this part is sorted, that means the guarantee is that this would be lower than this. And if my target is here, I'm good. If my target is not here, I need to go to the other side. In the same way, if this part is not sorted, but if this part is sorted, and if my target is here, I'm good. If I'm not, my target is not here, then I need to go to the other side. That's what like I think Safal has mentioned. So basically
Exactly.
how we change our low and high is the trick. Based on now we are adding some more conditions to this logic.
Yeah.
But if we remember in this way, I think in the interview we should able to like remember, okay, this is the approach we want to follow. Rest is a coding part.
Yeah, pretty much. Yeah.
But a little bit confusing it is for sure. Like every time,
Yeah, it is confusing. Only thing is we have to be sure that which side low and high are going.
Yeah. Yeah. Yep. I'm gonna stop my share.
Yeah, this is why what I did was I first found the pivot element. Then, since we know the pivot element, we can compare it with the target value. Now, if it matches with the target value, we will directly return the pivot element, the index of the pivot element. If the target value is greater than the greater, if the target value is greater than, I guess, the smallest value, the value at zeroth index is greater than the target value or equal to, then we know that our search space will be reduced to 0 to pivot minus 1. And
plus
if
one, yeah.
otherwise, our search space will reduce to pivot plus 1 to n minus 1.
So basically two searches, first finding pivot and then finding the target.
Yes.
Yeah.
So
Yeah. No,
so
that's
interviewer
another
could
approach I saw too. Yeah.
yeah,
But
but interviewer could
here,
say
which one you are considering as pivot? There are two options, right? You can either take it 7 as pivot or 0 as pivot, right? It
Yes,
depends on which
but
one.
it doesn't matter which one we choose as the pivot element. Even either we take the smallest segment or
No,
the
no.
largest.
Let's say the pivot is 7. All the values are less than like 7, either left side or right side, right?
Hmm. All right. So once we know that 7 is the pivot element, first we'll compare if the target value is directly equal to the pivot element or not. If
Yeah.
it is, we will directly return the pivot element, the index of the pivot element. But if it is not, then again, first we will check if the zeroth index value is
Oh, 0 to 0. Okay, got it.
greater than or equal to
Got it.
target or not. If it is,
Got it.
then our search space will reduce to this 0 to pivot minus 1.
Makes sense. Makes sense. Got it.
Otherwise, it will be pivot plus 1 to n minus 1.
Yeah. Got it. Thank you.
Yeah.
You can share a vision. Like if
All
you
right.
want.
Yeah, but there is another way also, right? We can actually find the lowest value index, and then you divide that, right?
Yeah, all right. So my implementation is pretty big. So first we are checking for the pivot element. So in the check pivot one, first we'll start with the mid element. Then first we'll compare if mid is less than high, and if the value at mid is greater than the value at mid plus one. So for example,
Adjacent check.
let us suppose. Hmm. So I think this shows that the value at mid is the largest element. So
Yeah.
we will return mid. So one of the pivot element can be mid. Or again, if we are checking if the value at mid is less than the value at mid minus one. So again, this will be the, I guess, this will
Lowest
be the
value.
smallest element.
Mm.
Yes. So again, we are returning. So either of these two can be the pivot element. Otherwise, if it is not, then we are again calling the check pivot function, but our search space has been reduced from low to mid minus one.
Oh,
So
okay. Mhm.
again, if this comparison fails, then our search space is in the other half of the array. So once we find the pivot element, uh, in the base case, I did this return minus one. If at since in the when the array is already sorted, what will happen is we will come somewhere in the middle, and uh, none of this condition will be satisfied, and then this value of low will become greater than high. So in that case, it will return minus one, and if it returns minus one, we can directly binary search for in the entire array. So I just wrote this binary search. We can directly uh, or I guess we can use the STL one. So this is simple binary search implementation. So this one is the base case when the array is already sorted. If it is not, then first we compare if the value at the pivot element is directly equal to target. So if it is, we will directly send the index, which is the pivot. If it is not, then first we will check if the uh, value at the zeroth index is greater than equal to the target value or not. If it is, we know that our search space has been between pivot -1 to the smallest index in the array. So this is 0 to pivot -1. Otherwise, it will call pivot +1 to n-1. So in this way, we could do this.
Yeah. So first pivot and then.
But Asim had a question on that also, right?
Uh,
Okay.
yeah.
Yeah, maybe. Yeah, maybe. Okay, no problem. But that's a good approach.
Can
Yeah.
I,
Yeah, Ajay. Yeah, go ahead.
shall I go ahead? Yeah. Okay. Let me share my screen real quick. Okay. So in here, basically, we have three cases. First is definitely the bingo, like middays pivot, and we found it, we return it. Okay. So the second one is left half of the mid is sorted. So we try to find out wherever the pivot lands up, whether it is case one, two, or three, some part of the array would be definitely sorted wherever the pivot is sitting. So if the left half of the mid is sorted, then I have two sub conditions. If at all value, the value which we are finding is greater than the larger and value is lesser than the mid, so basically we will see the window. And if it is not, if it is in there, then of course we will decrease down the right by mid minus, otherwise we definitely have to go the other way. So this will take care of it, and this is third is vice versa. I mean, it's the other side of it, so the second and third are identical rather than I mean, just these changes are there, so this is another way.
Yeah. It's the same.
and
Like left.
and yeah, I saw one note was there on my, it get confused, and again it, like, next time when I will try this question, so I will get confused. So yeah, I have noted down these cases itself, so that some memorization I have done for this question.
Mm.
Okay. Yeah.
Yeah. So uh, what we were doing is first we were finding the pivot element, but instead of finding the pivot element, uh, we can directly compare uh, in the binary search function itself.
This is what he's
Correct.
doing, right?
Correct. Yeah.
Yes,
Yeah.
yes. So, so we will be reducing one log n factor again.
Right. 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 So that is
Since we
what the
will be,
interviewer would surely come up with if we do it the
yes,
previous way. So then I think we'll have to come to this implementation or maybe the approach, right? Yeah.
Yeah, he'll push it to this
Yeah.
level.
Right. But even if the way Ajay or maybe Sapor also discussed almost the similar approaches, it looks very easy and very simple over here, but it's not that simple, right? Yeah.
Yeah,
You have to
you
be
can.
very careful about all of these stuff. Yeah. Yeah. These are good approaches.
And it was once asked me in interview also, so it,
Good.
So definitely this question will be, because it's like
Yeah, they are
yes.
important ones, right? Actually.
it's neither hard nor easy, but it will shake you
They
for
are
sure.
really
it,
important. Yeah.
yeah, it will have a healthy discussion in the interview. I mean, if you give me a super hard problem, there will not be much discussion at all. But if you give me a one with to grind and some question like that, then there will be lots of discussion, and then yeah. So this is a very um, interview famous question also.
Yeah.
Yeah, very good.
Santosh, were you asking more about me? Sorry, I was a bit.
Yeah, yeah. You had a question on the previous approach, right? Yeah. So I just thinking, do you still have or
No, I don't have any.
okay, no problem. Yeah, thank you.
But if this question comes to interview, I would say like come with the standardized approach. Like say first I will do linear, the complexity is order of n. Can I do something better than say, okay, it looks like these are sorted, so I can try binary search and then come up with try to solve the problem with your interview together. Just like you have solved yesterday and you got this question tomorrow, and then just not jump and start writing the code.
Okay. Yeah, that's important. Mhm. But then should
Because
we go at the first way? Like first we want to find the midpoint or the lowest point, and then divide the search space or maybe the array into two parts. That is the second approach we need to take after the linear.
I will say like just linear would be like one liner. That approach one is like, okay, linear complexity is order of n, but looks like I can do better. Let me think, I can do something with binary search. But this array is kind of rotated. One way is like finding a pivot, and then I know which half I can go. So finding pivot could be again like log n or order of n. But why to do order of n? I can do log n and find pivot. Now I can do another binary search to find my target. But now there are two searches we're doing. Can the approach three would be in one search only? Can I do only have to find whether I have to go left or right? So with some more condition, can I do that? And then if you explain and then if you have agreement with the interviewer, then code.
Okay.
Because the interviewer might have something else on his or her mind.
This one he will have for sure.
You never know what interview could be looking. And if okay, Shashank, can you open that question again?
Yeah, sure.
Let's see what are similar questions.
Yeah,
Yes.
that is important. Yeah, do we have that one right? Another one almost similar.
Research
So
sorted. Yeah.
Yeah, two.
yeah, so interviewer can, as soon as interviewer can see you are on the right track, can make it little hard by telling like if you open the search in rotated direct 2, I think there could be duplicates.
Yeah,
Oh,
to
that's where Sasang. Yep, yep.
Yeah, duplicates are there, right?
Yeah.
So it would be a follow-up question,
Mhm.
or it could be like interviewers say, or might be you have not clarified, and interviewer could take advantage of that
Mhm.
and say, hey, what you will do when there are duplicate elements? And some reason you thought this is Leetcode, whatever that 33 number question, there are no duplicates. Why this guy
Shashank
is
will
asking?
surely remember that number also, correct?
Yeah.
Okay.
That's funny. So, but let's say so on this too, just like Shashank said, right? If let's say if there was a duplicates, then
this part
then
just
we
that
will
way.
decrement. Yep. If it finds a duplicate, then decrement. Right.
Yeah. Otherwise, it's same implementation what you have done.
Okay.
I don't think so. It's that easy. Yeah, he has come up with very easy thing, right? It's not so easy also. Yeah, okay, you are doing it. Okay.
Yeah. It's like again we are this half is checking whether left half is sorted, and this is
Uh-huh.
checking the right half is sorted, and this is this one just to check whether you have duplicates. Then you can increase left and shrink the array kind of.
But you are checking here, both of them are same, right? The left, right, and mid, all of them together.
Yeah, that is duplicates. Yeah.
But if we have only one side duplicate, oh yeah, you will have one, okay, left and right. But why we are comparing with mid? Will mid also be a duplicate in that case?
Can be. Why not? Right. Um,
How many?
Should be R, right? Nums of mid equal to nums of left, or nums of mid equal to nums of. Oh,
So all the three.
And
Yeah. Go ahead.
So looks like the exact approach will work. Only the problem is if the duplicate is at the start and or at the mid level.
yeah,
Yeah.
So we don't know. Otherwise, they would be kind of together.
Together, I mean, what do you mean by together?
See, 6 6. If you go,
Adjacent. Okay.
and they would be adjacent. There could be chance when the rotation is happening in a way they get separated.
Definitely. Yeah. I mean, 1 6. Yeah.
I'm just trying to see example
This one
where
only,
they
example one, 2 2.
The first and last. Yeah.
yeah uh, not even this one so yeah, so I'm just trying to remember what could be the what could be like trying to come up what could be the trick here. See, although the previous approach it should work same, only thing is when twos got separated.
So, I mean, the left, let's say, right half is sorted and second half is all duplicates. Something like that, like 0 0 0 in the second half.
or maybe uh, first two elements are like same and the last element is same, like three duplicates.
Okay, yeah, after rotating.
Yeah.
Hey, but Shashank, on your line number 8, are you doing or here?
That's
Is it
what
like that?
my
I didn't come again.
So yeah, when you are saying in your line number 8, nums made equals nums of left, or is it like this, nums made equals nums of left, or nums made equals nums of right? Is it like that, or it is all of them are equal?
All of them are equal.
Really?
Yeah. Okay. You can check here. No problem.
No, I was just asking. Yeah, I didn't understand the Python syntax.
So you are saying like this, right?
Ishank, can I share my code once?
I think it should be left and right, no? Or maybe white should have. Yeah, maybe there are 3 more conditions. Okay.
yeah, even I got that out.
So let me share my screen, and I can't
Or is
remember what exactly I did. Okay, let me know when you can see my screen.
Yeah, we are seeing your screen. Yeah.
Okay, so if we remove this condition for a second, oops, sorry. Then the code is exactly same what we have seen earlier, right? If this part is sorted, then we are coming inside. If the target is between this area, that means our search space, the high should come to the mid.
Yep.
Otherwise, we are going on the other side. If the things are not sorted, we are going on the other side and say checking like if my target is between mid and high. If it is, then we are changing low. Otherwise, we are telling high should go on the other side.
Yep.
So this is exactly. Now, I remember I added this condition. So when low is less than and they both are same, just change the value of low and bring it to a place where they both are not same, low and mid.
Okay. So all the duplicates on the low side you are removing.
No, if low and mid are duplicate.
Low and mid are duplicate.
Yeah.
Because that is the way it is sorted.
Yeah.
Okay. So the whole of the left sub array you are removing almost, right?
because they are
It's not
duplicates.
exactly left sub array. We are just bringing at the point where low and mid are not duplicate anymore.
Mhm. Okay, yeah.
So
I
But
that,
can't-
why
yeah,
are you just doing it for low and mid? Like, what if it is sorted counterclockwise?
But that you can take care of.
Good question that I'm not able to remember.
Yeah, this is like if it's clockwise, then probably.
See,
Okay.
you have to remove duplicates only at one side. Okay, you
Yeah,
don't remove duplicates at the other side
to
also.
make this
Yeah,
condition work.
yeah.
Yeah, but it also depends on the way the array is rotated, right? If it is
No,
rotated from the left side, like if it's rotated counterclockwise, then all your low elements are actually towards the end.
do you
why
have example?
the
Like,
entire array is duplicate only then?
yeah, I mean, yeah, that is.
So
Yeah.
only thing is because we are always considering nums of low and comparing that with the mid, so that should not be duplicate, right? Other side, even if it is duplicate, that can be easily handled by or from line 20 to the rest of it.
So let's say if we have 2, and so we were having 2, and then we were having 3, 4, 5, something like this. This is not rotated. And then I decided to rotate this array from this place, like pushing all these elements on the other side. That I can do that, right?
Yeah.
So how it will rotate? 2, 3, 4, 5.
Double or triple. Okay, all the four to that side. Yeah.
Yeah.
So let's
Well,
say if this comes as mid, or let's remove 5 from here. Remove 5 from here. And if this comes mid, we're just trying to go at this place where we have this array.
Okay.
So to make a decision, otherwise we can't make a decision by looking these twos. By looking at these twos, we can't make a decision whether this array is sorted or not.
Yeah.
Correct?
Mhm.
So we are bringing our pointer somewhere here where we can make a decision. So we know this part is not sorted. And we might, if this part is not sorted, we might end up here. And if our target is not it, anyhow, the high will change here, and then we'll eventually come back this place. Like say we are finding 4. Then our search space will become 3, 4, 2. Does it make sense?
Yeah.
yeah.
Yeah. So again, I don't want like anybody like to memorize by heart, but this kind of conditions are always tricky.
Yeah.
Or
Also, like if you have like only you don't have two at the mid, okay? So if you have twos only at the right and left, okay?
What example?
Okay, if you have an example like the same example, you say 2, 3, 4, okay, and then you have 5, 6,
Hmm.
5, 6, and then two twos, 1, 2, and another 2, right?
Mm-hmm.
So in this case, if you see your condition when you say on line 17, if low is less than mid, okay, so in this case, your low might come somewhere on 5, right?
Yeah, but this condition doesn't match.
Yeah, that won't match, right? But still, you need to remove the first two, which is on the left side.
Which
Is it
one?
not?
2, 3?
Yeah, if you just because see, if you look at the left side, you have a 2,
Hmm.
okay, and then you have another 2 on your right side also.
Mm-hmm.
Correct. So if you remove the 2 which is on the left side, okay, so then your 3, 4, 5, because if you look at the pivot now,
Mm-hmm.
okay, so 3 is whatever your pivot will be, your 3 will always be because you're now left and right are not same. The extreme left and right, they are not same. So that doesn't actually form a rotated array. And if it's a duplicate, you should take care of that, right? So you should take care of the left side always. So left side should always be greater than your right side, correct?
I think um, uh, I couldn't get it fully, but my interpretation is like to make this condition work, we are doing this work.
Why
Yeah.
not we just check? So instead of on the same, on the earlier code, instead of while loop, let's say else if just nums low equals to nums mid, and then increment the low.
But we have to increment it to a level where this condition could work. Because this condition is the like heart of this question.
Yeah.
We are trying to find if this array is sorted or not.
Mm-hmm.
If we are able to fail in this condition, there could be possibility this array is sorted. Correct?
Yeah. Yeah.
Like if I have all twos here, this could be sorted. So the problem lies to bring to this level where we can make a decision. Otherwise, it will always go to else.
Yeah.
That's what is my understanding. Like to just make sure this condition work, we are supporting with this while loop.
Okay.
And
No, I think even else will work, right? The first while loop will take care of it, I guess.
yeah, so to make these if and else work.
Yeah. Immediately, yeah.
And what we can do, we can remove this and see which test case it fails, which can give us better clarity what you guys say. Or if we don't have time, let's proceed with the next question.
Yeah.
Explain might come on its own course.
Yeah. Plus, this is another problem, anyways.
Yeah, but maybe we can discuss this one of the session. This is very important. All these all the edge cases we should discuss, I would say.
Yeah.
Because this may come as a follow-up to that question. Because as soon as the interviewer say you cracked it, let's make it complicated.
Yeah.
Yes. Yeah.
And then coming up with this condition is important, like how, because I think this is a corner case which we are trying to solve now here, which this condition would complement that kind of.
Yeah, these all those 2-3 cases are very important. Should go one by one and satisfy ourselves. Yeah. Okay. Let's make a point to discuss this in some session.
Sure. Okay.
Yeah, sure.
I can real quick discuss my sorry. Can I share my solution on 940?
Yeah.
All right. Okay.
Can you be a quick, because
yes. Okay. I will try to be.
Sure.
Yes. Okay. So this was the last one we discussed, like search with 1 case, 2 case, 3 case. So similarly, like in here, we got mid. Okay. After that, we search the left side has the element. Okay, left side has the element. Then again, we have the set of conditions. And if right side has the element, then we have a set of condition. What if we don't have rotation? Then we just put it into else. That simplifies the cases. So here, basically what we are doing, if at all, whichever we 3 cases we are seeing, we did not find it, we find the no rotation. And in no rotation, we go from the right minus minus, because we have to pick up the first element with the duplicates. It has the duplicate. So at the end, we basically check if the L is equals to the target. Target is the value we are looking for. And if it is there, then we return true. Otherwise, we return false.
Okay. So you are actually removing all the duplicates on the right side, right? Okay.
Yeah.
That is also one good value.
Yeah,
quick
I mean,
approach to do it. Yeah.
there are multiple approach to this problem, so I would suggest to just stick with one and exploring that one. So that one helped. So yeah,
Yeah.
Yeah.
that's
This is good. Yeah. Absolutely.
thank you.
No problem. Yeah, sure. Thank you. Yeah. Shashank.
Yeah, sure. So here actually it was and operation. I mean, mid equal to left and mid equal to right and left equal to right. So that three, I mean, equal what I was doing, mid equal to left equal to right, that was and.
Oh, it is all of them together. Uh-huh.
Yeah,
Okay.
all of them.
Maybe we take all of these cases, in one of the session. Okay, along with all the edge cases, what Asim said,
Yeah,
and also what Ajay said. All of them, and we discuss.
right. This
Mhm.
one.
Yeah.
That
Okay.
was more.
Yeah. Sure.
So last question is like, I mean, we are given n cross n grid and we have to place some of, what do you say, one cross one cube, which the value of B is grid ij, which represents a tower of B cubes placed on the top of the cell. Now, after placing these cubes, we have decided to glue any directly adjacent cubes to each other, forming irregular 3D shapes. You have to return the total surface area of the resulting. Yeah. So this is two, and we are, what do you say, 3D we have to make. So it will be five, right? I mean, four such on the all the four sides, two to two. You will, what do you say, paste it, right?
Right. And then still you have to take the top and the bottom also.
Bottom, yeah.
Mhm.
So
So
this
I
is
was
a
thinking like you have a cube, so it will rest on some plane, right? So the
okay.
bottom surface should not appear, right? It looks like,
It will be down here, bottom with it.
yeah. So they are actually hanging in the air. It seems now.
Or diagonally they might be hanging so that
Maybe, yeah.
orientation, yeah, something like that.
Yeah, but that's not very clear in the problem statement also, right?
Yeah,
And he's
yeah.
not saying that because we always assume that some
No,
object is there.
it's
It will
mentioned.
always be.
He has mentioned this bottom face of each shape counts towards its surface area.
Each surface counts towards, yeah. So it means, yeah. So this is a clarifying question only, right? Or else,
Yeah,
hmm, very important.
in that case. Yeah. So how do we do here? I
But
mean,
frankly,
this.
this problem is not that easy. Also, it looks
Yeah,
very
exactly.
bad.
I mean,
Yeah.
all the three axes they are exploring and then calculating the area. I thought that it would be simple. It should be easy one. The way they
It
have.
should not
So
be easy.
first we should start from checking if uh, uh, a individual block is contributing to top face area and bottom face area or not. Then we can check for how it is contributing to the sideways in the total surface area. So if it is at the extreme ends, then directly the value can be added for the sideways. But if it is in the middle, then we have to check from all the four directions.
Oh,
Mm-hmm.
Since
so
the difference of heights will give us the surface area in when the block is in the middle. So
Okay.
we can take the absolute difference of the height of the blocks that can give the surface area in the intersection of two blocks.
mm,
I think looking at the 2D figure, it is not so clear, but
yeah.
if we visualize it in the 3D form, then directly we can say that the difference of the height will be the surface area contributing to that intersection of two blocks part.
Mm-hmm. But you still have to start with the top left corner, right?
Yes. First, that is what first we need to check how it is contributing to the top area, then bottommost area, and then sideways or the extremes. Like
Hmm.
here, one, two, three, four, all the four are contributing to the extremes.
Mm-hmm.
So one will be contributing two times, two will be contributed two times, four, three. again 2 times.
Mhm.
Yeah, want to share?
Yeah, so I made four variables: top, bottom, sideways, and middle. So top just gets the value if it is greater than 0 or not. So like here, this 0 will not contribute to either top or bottom face since the area is 0. No, since the height is 0. Now, first we will need to check if it is at the extreme point. Like this one is at the extreme in the row, then this one is also extreme in this row. So I equal to 0 and I equal to n minus 1 is the extreme point for the row, and j equal to 0 and j equal to n minus 1 is the extreme for the columns. So for the extremes, directly the height will be contributing to the surface area. Now the main point is the middle. How we have to take the surface area when two blocks will be intersecting. So if you visualize this 3D, then if two blocks are of different height, then we just need to check how much height difference is there in the intersection part. So if we get the height difference, that will be the surface area it will be contributing. So if
Yeah,
a
because
block is in
same
the
area will overlap. Okay. Yeah.
yes, so if a block is in the middle, it has four possible ways to intersect with the blocks. So uh, we just need to check if it is not violating the this constraint value. Like this one will have only two blocks to overlap. Uh, Again, this one will have three blocks to overlap. This zero will have four blocks to overlap. Since diagonally there can't be any intersection between two blocks. Uh, no, there will be intersection, but there will be no overlap of surface areas. So we don't need to check for the diagonal part, but we need to check in the uh, four parts. So just we need to check the previous one does not go negative. The after one does not go beyond n. Same for row and column. But we must keep in mind that since for each block we are checking uh, the middle one, so for even for one I will take the contribution of 0, and for 0 I will take the contribution of 1. So the overlap is counted twice. So in the final answer I will just return middle by 2. So the contribution which was taken twice, I will be first dividing by 2, then I will be adding in the total answer. So top, bottom, sideways, and the middle. This will be the final answer.
It's a different way of doing it. Okay. So that is what the middle you have to divide by 2.
Since we have only four ways to take the surface area, so I just take how it will be contributing to the top face, bottom face, and in the extreme sideways, and when it will be colliding with other blocks in the middle. So four variables, and then it is easy for
Yeah.
taking all the conditions.
Yeah, because you're taking the absolute value, right? In that case, from line
Yes,
23 to 26, that is the reason we'll have to do it. Okay, makes sense.
yes. So absolute value will give the
Hmm.
this overlapping surface area.
Yeah.
Mm. Yeah, it's more clean
Yeah.
code also. Yeah. Mm.
The more of a visualization problem. I mean, in
Mm.
3D.
Yes, yes. Since it is 3D, so if you see the 2D one, 2D phase, then you won't be able to visualize. But the if you think of in that 3D space, then it will be pretty easy to take into consideration these four variables.
Mm.
Yeah.
Yeah,
Yeah, makes
that's
sense.
what.
Yeah. Yeah.
All right.